sites. One of the topics that a lot of people find confusing is that of Active Directory sites, and it really needn't be as confusing as you might think, since Active Directory sites are really only groups of IP subnets connected by a fast, reliable link. The structure of an Active Directory site mirrors the geographic location of your users and is maintained separately from the logical structure of the domain and not necessarily the physical location of where your servers are. Now, sites are independent from the domain, which means you can have one or more sites in a domain or one site spread across multiple domains. Now, the main purpose of a site is to physically group computers together to optimize your network traffic. Sites can confine your user authentication and replication to only the devices contained within the site. So, in other words, we want to use sites to group together a bunch of computers that are in most cases situated close together. They can be on the same subnet or separate subnets, but they're all able to communicate over a fast link, which is normally a local area network. So sites have two main benefits to us. They can improve logon times, since users will authenticate with a domain controller that's local to them in their site, and secondly, we can control replication between our domain controllers for better performance. So if you think about your own corporate network, maybe you have a head office with the majority of your users located there. You might also have one or two or even dozens of smaller offices located elsewhere in the state, in the country, or even in other countries. Now, generally speaking, you'll most likely have fast connections within each of these offices, since they'll be connected to each other locally using 100 megabit or even gigabit LANs. So anything that you need to do at the office you're located in is normally pretty quick. Now, how are your other offices connected together? What speeds are the connections between your offices? When a head office communicates with one of the local offices, is it using a fast link or a slow one? Whatever the speed, it's probably a safe bet to assume that any internal communication within an office is faster than the connection you'll have when you access one of your remote sites. And that's really what sites are all about, grouping together those high-speed areas like your LANs and working out how to manage replication to the other offices utilizing the connections that you have. Now, it's replication that ensures that a change that's made on one domain controller is synchronized to other domain controllers within your domain. In Active Directory, all of the objects in the forest are represented in the directory tree. So for each forest in your network, the directory is partitioned to allow sections to be replicated to domain controllers in different domains within the forest. Each domain controller stores a copy of a specific section of the directory tree called a directory partition. Now, there are at least 3 types of directory partition replicas stored on each domain controller, depending on your configuration. We have the schema partition, which contains definitions of objects that can be created in the forest, and the attributes that each of them can have. Objects in the schema partition must be replicated to all domain controllers in the forest. Now, the configuration partition contains objects that represent the logical structure of the forest, including the replication topology and the domain structure. The domain partition contains all of the objects in a domain, and these objects are only replicated to domain controllers within the domain. And finally, we have the application partition, which is only available to domain controllers running Windows Server 2003 or 2008. This partition stores application-specific data, and of course it can be configured to replicate objects to any domain controller in the forest. So, with that in mind, what triggers replication? Well, replication can be triggered by time. Well, sort of. Replication partners will poll each other periodically at specified intervals. But replication doesn't really occur until something's changed. So, creating, moving, modifying or deleting any object will trigger replication between domain controllers. Now, local replication occurs every 5 minutes and happens when a domain controller notifies its replication partners that something's changed. Now, the replication partner will then pull the change and modify its own replica of the Active Directory database. Now, if a domain controller doesn't have any changes to replicate, it won't tell its partners that it doesn't have any changes, it just sits there and remains quiet. But if there's been no replication occurring within an hour, it'll contact its partners just to ensure that they're still up and responding. Active Directory replicates information in two ways, either using intra-site or inter-site replication. Intra-site replication between domain controllers occurs within a site. So at my head office here, I might have 3 domain controllers all belonging to the same site. These domain controllers will replicate with each other, and since they all belong to the same site, this is called intra-site replication, as they are replicating internally within the site. Now, when intra-site replication takes place, to save CPU processing time, the replicated data is not compressed, since compressing the data only means the CPU has to do more work. Now, since we're within a site, and remember, within a site, we're supposed to have high-speed links, so compressing data would probably only waste time and unnecessary CPU cycles, so we don't bother compressing it, we just transfer it as it is. Now, when we're dealing with intra-site replication, replication only occurs when a change is notified to its replication partner. The replication partner then pulls the change and then merges it into its own database. So if a change is made on domain controller number 1, server number 1 will tell the other domains that it has a change, and then domain controllers 2 and 3 will pull the update from server 1. Now, this replication occurs every 5 minutes using a remote procedure call. Now, inter-site replication between domain controllers, however, only occurs between sites. So here we have 2 sites. We've got head office and New York. Now, when these 2 sites want to replicate data, they'll be performing inter-site replication over a WAN link. To save on WAN bandwidth, replication data that's greater than 50 kilobytes is compressed, and unlike intra-site replication, inter-site replication partners do not notify their partners that a change needs to be replicated. Instead, one domain controller in each site will act as what's called a bridgehead server, and that handles the replication to the bridgehead server in the other site. Now, this inter-site replication occurs during scheduled periods, and if there have been directory changes and replication is required, then the changes are pulled to the domain controllers that require the changes. Now, unlike intra-site replication, inter-site replication doesn't use remote procedure calls, it uses the Internet Protocol, or SMTP. Now, replication occurs in a loop that goes in both directions. So, for example, if we have 3 domain controllers here configured as replication partners, and domain controller 1 has a change it needs to replicate, it'll replicate in both directions to domain controller 2 and domain controller 3 at the same time. The Knowledge Consistency Checker, or KCC, is a program that runs on every domain controller, and it checks every 15 minutes for any new domain controllers in the domain. And if it finds any, it's going to automatically readjust this replication loop to accommodate the new domain controller. However, the KCC doesn't actually appear as an executable in the task manager. lsass.exe is the actual executable that calls KCC to do its work. So therefore, monitoring the performance of this executable is a good method of determining how your domain controller is performing. Now, if you see the CPU time frequently around 100%, when this executable is busy, it might be time to consider adding additional domain controllers. Now, site links are logical, transitive connections between 2 or more sites that mirror your network links to allow replication to occur. So, even though we have our 2 offices here, connected by a 512K link and a 1.5 megabit link, don't confuse the physical link itself with a site link. The site link is just a setting, if you like, that we can configure to tell Active Directory that one site should link to another for replication purposes. Now, once these site links have been created, the KCC will automatically generate the replication topology by creating the connection objects it needs. Now, these site links must be created manually, and they're used by the KCC to determine replication paths between the 2 sites. Connection objects, on the other hand, are automatically created by the KCC, and they perform the function of connecting domain controllers, although you can create these manually if you wish. Now, by default, all site links are transitive. Now, this simply means that if Site A and Site B are linked sites, and Site B and Site C are also linked sites, then Site A and Site C are also transitively linked sites. Now you can disable transitivity, but disabling it will cause all site links to be affected, and the result being that none of them will be transitive. So why would you want to disable transitivity? Well, if you don't want replication to be handled automatically, or you want replication to occur over a specific path and not an automatic one, such as a path where a firewall might affect replication, then disabling transitivity might be your only choice. Or perhaps, if your network's not fully routed, or it is routed, but you have so many routers that you don't want the KCC to take into consideration, you might also like to disable transitivity. Now, a site link bridge connects two or more site links. Because site links are transitive by default, you'd hardly ever need to go and create a site link bridge. In fact, if you have site links enabled, then creating a site link bridge will do absolutely nothing at all. But if site link transitivity is disabled like we discussed a moment ago, then you will need to manually create a site link bridge. Now, we have three sites here, site A, B and C. Now, site A and B are connected by a site link, and site B and C are also connected by a site link. Now, even though sites A and C don't have any site link directly connecting the two sites, they can still replicate with each other as they're automatically bridged. Now, when you have configured your sites and site links, the KCC automatically selects a domain controller in each site for inter-site transport. This server is known as the bridgehead server. The bridgehead server becomes the contact point, if you like, for replication between sites. When the bridgehead server receives replication updates from the bridgehead server in the other site, it'll replicate those updates to the domain controllers in its own site. Now, you could specify multiple bridgehead servers if you like, but only one will ever be active at any time. Now, if you're setting your bridgehead servers manually, it's a good idea to specify multiple servers. The reason for this is fault tolerance. If the bridgehead server goes down, then replication between these sites won't occur, even if you do have other valid domain controllers sitting there which would be able to do the job. But if you leave the KCC to handle bridgehead servers automatically, then it will automatically choose another server to be the bridgehead if your original server fails. Now, bridgehead servers replicate data in the following way. The bridgehead server in Site A polls the bridgehead server in Site B to find out if Site B has any updates. And it'll poll the server in Site B according to the replication frequency that's set out in the Active Directory Sites and Services MMC. Now, if Site B does have updates, it'll send the updates to Site A. If the data is greater than 50 kilobytes in size, it'll then first compress it before transferring it to Site A. Now, once all the data has transferred to the bridgehead server in Site A, it'll then replicate this data to the other domain controllers within its site. Now, as this replication is intra-site replication, it doesn't need to compress the data. Now, hopefully so far we've given you a better understanding of what sites are and the technical jargon associated with sites. But before we get on with the business of actually configuring sites on Windows 2008, let's quickly discuss what improvements we have with Windows Server 2008 when it comes to sites, and some other benefits that might not be the result of direct changes to sites themselves, but overall will affect your sites for the best in some way. Now, first of all, in Windows Server 2008, we now have the ability to create a read-only domain controller, or RODC, and this is a special type of domain controller that, as the name suggests, is read-only and can only be updated from a fully functioning writable domain controller. Now, we do have another video dedicated to read-only domain controller, so I'd encourage you to go and check that video out. But why this is good for our sites is that read-only domain controllers, coupled with universal group membership caching, can reduce the overall amount of global catalog servers needed, and that can significantly reduce the amount of replication traffic in your network. Now, speaking of global catalog servers, in Windows Server 2008, when any changes need to be made to the Active Directory schema, no longer do we have to replicate the whole schema, we can just replicate the changes, and that's going to mean less replication traffic on your network. As will replicating from media when you install a new domain controller. You see, when you install an Active Directory domain controller in your network, it needs to grab a current copy of the Active Directory database from one of the other domain controllers in your domain. Now, in Windows 2008, we can now dump this replication data to media, physically ship it to the site where the new domain controller will be installed, and then apply that replication traffic locally rather than having to have all of this data sent down a potentially slow link. Windows 2008 also supports running Active Directory using a server core installation, which not only lowers overhead required for the domain services role, but it also makes it more secure by reducing the overall attack surface of the server, since all of the unnecessary services that you'd find on a full Windows Server installation will be disabled. Now, there's also been some algorithm improvements made to the KCC in Windows 2008 to speed things up, and most of it's geared around supporting read-only domain controllers. Now, previously, when a group in Active Directory had changed, maybe you'd added or removed some users from it, Active Directory would replicate the entire group membership to all other domain controllers. Now, Windows 2008 now uses linked value replication to replicate only the necessary changes and not the whole group. Also in Windows 2008, we can now disable replication packet compression. And whilst that might sound strange, why would you want to disable compressing packets? Won't that make the overall data that's needed to be replicated larger? Well, yes it will, but compressing data also takes up CPU time. And you might find yourself in a situation where you have plenty of bandwidth, but you're now maxing out your CPU time. So to alleviate the burden on the CPU, you're now able to turn off compression. So whichever category you fit into, whether you want your CPU doing less work or you want more bandwidth, there's now a solution to make both of you happy. Finally, in old versions of Windows Server, you could run into a situation where if your domain controller was down for an extended period of time, which was longer than the tombstone date for the deletion of certain objects, when the domain controller was brought back online, these dead objects could be replicated to other domain controllers, and then they're still active in your network. Now, these were known as zombies, presumably because they arise from the dead, but Windows 2008 can now detect these zombies, isolate them, and get rid of them. Well, so far in this video we've talked a bit about what sites are, so let's move on and we'll go and configure a site. But to configure a site, we've got to do a couple of things. Now, first we'll need to create the site in Active Directory. We'll then need to create a subnet and associate it with the site, and then we'll need to add a domain controller to our site. And we can either create a new domain controller or move an existing one into our site. So we're done with the theory for now, so let's get stuck in and configure a site. So to do that, we'll need to click on Start and choose Administrative Tools, and then choose Active Directory Sites and Services. Now, by default, over on the left here, if we expand Sites, we already have a site created called the default first site name. Now, if we expand this, and then we expand Servers, at this time I have 3 domain controllers all configured in the same site. Now, the default first site name is, as the name suggests, a default site that we really should change. But when I created these 3 domain controllers as part of the DC promo wizard, I was asked which site these should be joining. Well, since I haven't configured any sites yet in this forest, by default they'll all be dropped in here, but that's fine, we can certainly fix that. So first, let's define our sites. Now, I've got 3 domain controllers here, and if we click on the servers container, you'll see over here in the right that our server DCO1 is my domain controller at head office. We've got another server here, DCO3, which is the domain controller in my London domain, and DCT01 is the domain controller in my New York domain. So the first thing we really need to do here is to rename this default site to something a little more meaningful to our environment. So we'll right click on it and we'll choose Rename, and let's say for argument's sake that my head office is somewhere in the US, so we're going to rename this to US. Now, since the head office is in the US, and obviously New York is also in the US, it's fine for me to keep both DCO1 and DCT01 here in this site. And so far, we have one site, but 2 domains within that site, and that's perfectly fine. So the next thing we'll need to do is to create a subnet to associate with this new US site. So up here, we'll right click on subnets and we'll choose New Subnet. Now we'll need to provide the subnet address using either the IP4 or IP6 formatting. So for my lab here, I'm going to enter in 10.32.0.0/24. And down the bottom, we'll need to associate this subnet with a site, so we'll select US and we'll click on OK. Now if we expand subnets, you can see here that our subnet has been created. Now don't underestimate the importance of these subnets, since what they do is serve to localize the objects within a domain. For example, when a user logs onto the domain, their workstation will attempt to contact a domain controller on their subnet or site so it's closest to them. Now, you can of course create multiple subnets within a site, so if you've got 10 subnets at head office, for example, all connected via the local LAN, then they can all be configured in the same site. Now the next thing we may need to do is to move the US domain controllers into our US site. Now in our case, we've already got our 2 domain controllers listed in the default site, which we renamed to US, so this step has been done. So what we'll do is we'll now go ahead and we'll create a second site so we can fix up London over here, which obviously is the odd one out, since both of our other domain controllers here are in the US. So on the left here, we'll right click on the sites container and we'll select New Site, and we'll call this site UK, and we'll select the default IP site link here and click on OK. Now since we're actually creating a whole new site here, not just renaming the default one, we'll get this message here that tells us that we'll need to create site links for this site, add subnets, and put at least 1 domain controller in the new site. So we'll click on OK, and we can see the UK site here has been created, but if we expand it, you'll note that we don't actually have any servers in here yet, but we'll get to that in a moment. So the next thing we'll do for this site is to create another subnet. So we'll right click on subnets again, we'll create a new subnet, and this time in our lab we'll use the IP address of 10.64.0.0/24, and down the bottom again we'll need to associate this subnet with a site, so this time we'll select UK and we'll click on OK. Okay, so up here we can see our subnet has been created, so the next thing we'll need to do is to move our UK domain controller into our UK site. So if we select our servers container here, we can see that the domain controller for London is DC03, so we can either right click on it and choose Move, and then select the site we want to move it to, or we can simply drag and drop it into the correct container. Now when we do that, we will get a warning message asking are we sure we want to do this. Of course we're sure, so we'll say yes. Now by the way, I did neglect to mention that now that we have our subnets here created, if we were to install a new domain controller somewhere on our network, it'll automatically be added to the correct site based on what subnet we install it to. So that's a bonus. So we started off with the 1 default site that you'll get when you first install Windows Server 2008, and by default all of our domain controllers in our forest were dropped into that site. But is that really a problem? Well, yes it is, because when we have all of these domain controllers in the one site, Active Directory will want to replicate to all of them using intra-site replication. But since London is in another country, which will be connected via a WAN link, we need to have it in its own site, so inter-site replication to that site can be managed better, and in the event that the WAN link goes down, it doesn't affect our US site. So by renaming our default site to US and then creating a new UK site and moving the London domain controller in it, we now have 2 sites, one in the US and one in the UK. Now, you'll also note that we have 2 domains in our US site and only one in our UK site. Again, sites are not governed by domain boundaries. Sites are what we configure based on our physical areas of high-speed access and IP subnets. So when DC01 and DCT01 replicate with each other, since they're in the same site, regardless of the fact that we have 2 domains here, like I said, domains are irrelevant, we'll be performing intra-site replication, as these 2 will be replicating with each other within the same site boundary. Now with DC03, if we were to add more domain controllers to London, it will then perform intra-site replication to those domain controllers, but if it replicates with any of the US domain controllers, then Intersite Replication will be occurring, since DC03 will be replicating with another separate site. Now that we have our sites defined, we'll need to configure Intersite Replication. Now you might recall that when we first created our UK site, we only had the option of using the default IP site link. The fact is, when we create inter-site transports, we actually have two options, IP and SMTP. Now, even though it's listed as IP over here, IP is in fact actually RPC over IP. Now, since IP transport site links communicate synchronously, which requires each replication transaction to complete before the next one can be sent, this means we'd want to use the IP transport option when we have reliable links that connect sites. However, to use SMTP, you must have an Enterprise Certificate Authority available, as the SMTP option will encrypt the traffic. So, if you do have the ability to use the SMTP transport, you should use it when your links are unreliable or not always available. SMTP is asynchronous, which means that replication transactions do not have to complete before another one can start, because the transaction is stored and it will be sent when the destination server is available. Now, the certificate authority is required for SMTP because it signs SMTP messages that are exchanged between domain controllers, ensuring that they are in fact authentic. Now, final requirement of using SMTP is that you can only use SMTP for connecting domain controllers in different domains. Now, even though we have two options for inter-site replication, IP and SMTP, intra-site replication only uses RPC over IP. So, to set up our site links, we'll first need to either select IP or SMTP, and then right-click and choose to create a new site link. Now, we'll need to supply a name for our site link, so we'll call this one US to UK, and then we'll need to select two or more sites to connect. Now, since we only have two sites, it's already selected our UK and US sites here, so we have nothing to do but click on OK. And there's our new site link. Now, if we want to rename or delete this site link, we could simply right-click on it and choose Delete or Rename, but let's select Properties to see some of the other options we have. Now, the first thing we can do here is to add in a description, and as we continually mention in these videos, it's a good idea to provide a meaningful description so we can easily identify the purpose of this object later. We can also see over on the right here that the US and the UK sites are included in this site link. Now, we could add or remove other sites following the same process we used when we created this site link. Now, down the bottom here, we can also configure the site cost. Now, site cost is what allows us to specify a priority, if you like, for the site link. Now, if we had two links, say a fast T1 and a very slow dial-up connection, we could configure a higher cost for the dial-up connection and a lower cost for the T1. Active Directory will always use the lower cost unless it's not available. So the T1 would always be used in favour of the dial-up connection. Now, I've only got a single connection here in my lab, so a priority here for me doesn't really mean very much, but it's extremely important in an enterprise situation where it's highly likely that you'd have additional connections for redundancy, so configuring the cost correctly will ensure that Active Directory uses the correct link, which in this example would be the T1. So if we consider this example here, we've got three different sites, Australia, US and UK, and each of these will be connected via some sort of WAN link. So let's say that between Australia and the UK, we have a 512K link. Between the UK and the US is a 1.5 megabit link, and we have a 128K link between Australia and the US. Now, we can assign a cost to each of these links, and remember that the lower the cost, the higher the priority. So now the link between Australia and the UK has a cost of 10, between the UK and the US is a cost of 5, and between Australia and the US we have a cost of 20. So even though by looking at this diagram here you might think that Australia would prefer to replicate with the US over the 128K link with a cost of 20, but no. In actuality, it'll choose to replicate via the UK, since even though it has to travel through the UK site to get to the US, the overall cost is lower. 10 plus 5 equals a cost of 15, whereas the 128K link has a cost of 20. However, if this link between the US and the UK goes down, it will revert to the next lowest cost, which in this case is the 128K link between Australia and the US. So remember, especially if you're planning on sitting Microsoft exams, it's always the lowest overall cost that it's going to be the preferred communication path. Alright, back on our server we can see here that the replication frequency defaults to 3 hours. Now this setting tells Active Directory how long it should wait before it uses the site link to check for replication updates. And here we can set replication to a minimum of 15 minutes and a maximum of 1 week or 10,080 minutes. Now, obviously the site link must of course be available for replication to occur, so if the site link is not available when replication is scheduled to occur, then replication doesn't happen. But we can also change the schedule of replication by clicking on the Change Schedule button. Now by default here everything is in blue, and this means that replication will occur by default at any time. So in our case, replication is scheduled to occur every 3 hours, 24 hours a day. Now by the way, if we cancel this, and we'll right click on the IP folder itself and choose Properties, this box here to ignore schedules, if that's checked, then the schedule that's specified in the site link we just looked at will be overridden. Now while we're here, the other option we have is to disable site link transitivity. Now by default, all sites are linked transitively. Now you'd disable this if you wanted to allow replication through sites that are separated by a firewall. Now if you do disable site link transitivity by unchecking this box here, then you'll need to manually create your site link bridges, so let's go and see how we can do that. Well, firstly we'll need to either right click on our IP or SMTP folder and we'll choose New Site Link Bridge. The first thing we'll need to do is give this site link bridge a name. I'm just going to call this one Test here, and then choose 2 site links from the list and then click on OK. And it's as simple as that to create one. Now, you might also recall back earlier in this video when we talked about bridgehead servers, you learnt that the Knowledge Consistency Checker, or KCC, automatically designates bridgehead servers, which are simply a server in each site that handles replication to a bridgehead server in another site. So if we go and take a look at our UK site over here on the left first, because we only have one server, therefore we know it's automatically going to be a bridgehead server since there aren't any others to choose from. So if we expand our server and select NTDS Settings, in the right hand side you can see we've automatically got created connections with both DC01 and DCT01 from our US site. Now the reason we have 2 connections with 2 servers here is that they're both bridgehead servers, since they're in different domains, and the KCC will automatically designate one server in each domain as a bridgehead server. But if you'd rather specify your own bridgehead server and not use the automatically designated ones, you could do it by right-clicking on the server that you want to make a bridgehead server and then choose Properties. And on the left here we can see IP and SMTP, so we'll select IP and click Add. Then when we click OK, this server would now be configured as a bridgehead server for our UK site. Now if you do have multiple servers in a site and you want them all to act as bridgehead servers, you'd simply repeat this process for all those servers as well. But remember, only one will ever be active as the bridgehead server at any time, so the others won't be used as bridgehead servers unless the primary server is unavailable. Now this is important to understand. You see, since these bridgehead servers are automatically by default designated by the KCC, we don't have to do anything, and if that server goes down, the KCC will automatically switch over to another server in that site and then make that one the bridgehead server. When we manually configure our bridgehead server, we do lose the automatic failover capability if we've only configured one server to be the bridgehead. Now, if you do have multiple domain controllers in each site and you want to manually create your bridgehead servers, the solution is to make at least 2 domain controllers into bridgehead servers, and you'll still have a failover if the primary one goes down. Now, as a side note, you can also use the repadmin command with the /bridgehead switch, and that'll help you identify which domain controllers in your network are in fact designated as bridgehead servers. Or you could use the Replication graphical application from the Windows 2003 support tools, although I will admit at this time there are known errors with those support tools running on Windows 2008, and Microsoft haven't released anything for 2008 yet, so keep your eyes peeled for some new support tools from Microsoft for Windows Server 2008. In fact, while we're on the topic of bridgehead servers, if we select either of our 2 sites here, US or UK, and then on the right hand side of our console here we'll double click on NTDS Site Settings, you can see in the middle the Inter, and note that keyword there, Intersite Topology Generator, which is DC03, or in other words, the bridgehead server for this site. Now, at this point, it's probably a good idea to discuss the connection objects themselves. We've already talked about how the KCC creates and manages these connection objects automatically, so let's go and take a look at the properties of these, and we can learn how to create our own connection objects. Now, you'll find the connection objects under the site server, and you expand the server and choose NTDS Settings. And in the right hand side you can see our connection objects, which is set to be automatically generated from both DCT01 and DC03. So we'll right click on one of these and we'll choose Properties. Now from this window here you can add in a description if you like, but one thing I will point out here is that if you change anything in this window, and I mean anything, for example even adding a description, once you click Apply, doing so will change this connection object from an automatic one to a manual one. So that's something to be aware of. Now if we click on the Change Schedule button, this will allow us to alter the replication schedule. Now the default intra-site replication is once per hour, but we can change this to none, to twice per hour, or to 4 times per hour, which of course is 15 minutes. But if you do change the schedule, again, you will be turning this into a manual connection object. Now finally we can change the replication partner here by clicking on the Change button and then selecting a domain controller that we wish to replicate data with. Now if we do want to force replication to occur, we can right click on the connection object and then choose Replicate Now, and this will force Active Directory to start the replication process with DCT01 in this case, and this replication won't affect any scheduled replications you might have configured. This will just be an additional one-time replication with the selected domain controller. Now if you do want to create your own connection objects, we can right click on NTDS Settings and choose New Active Directory Domain Services Connection. Now this will bring up the Find Domain Controller dialog box, where all you'll need to do is select one of the domain controllers from the list and then click on OK. So let's just choose one here. We'll pick DC03 and we'll click on OK, but since I've already got an automatically generated connection object, I'm going to get a warning message here asking us to confirm our decision, but for the purposes of this exercise we'll just click Yes. And now we'll need to enter in a name for the connection object, so I'll just accept the default here of DC03 and click on OK, and we can see there our connection object has been created. In this video we've discussed in depth sites and replication. We've talked about the different transports sites use to replicate data via their connection objects. We also discussed creating site links and site link bridges and how replication